We thank you how far you have brought us, and we pray that as we're in this lesson, we may concentrate and put all anything that would disturb us aside. We pray that we may be able to remember whatever we're taught, and that you may give us the wisdom and understanding that we need. Bless you in the mighty name of Jesus Christ, I pray. Amen.
Johanna, I'm not hearing you, though I can say amen.
Oh, I finished praying.
Girls, are we still hearing you? Okay, Amina. Okay, students, as we wait for our main teacher, let's begin. Then when she comes in, she will join us. Okay, let me share. We are basically going to continue discussing our topic of writing chemical formulae, and we will make sure that we finish today. So if you have any questions, you need to ask all your questions today, such that next week we can start on a very good note, because we want to start on chemical equations, how to write equations. That's where we'll be going next week. Let's pray that today won't get internet issues or any connection challenges. So last week we finished this first exercise. I'm going to be using my screen today. Last week we finished this exercise, though I told you to do the last two numbers: sodium phosphate and aluminium sulfate. How many of us tried out those two numbers, or tried those two numbers? Those who tried to do those two numbers, you can just raise up your hand. Those who tried to do the two numbers. Cynthia, your microphone is unmuted. You can unmute. Yes. Okay, I see very few hands raised. I don't know if you all tried out those two numbers: sodium phosphate and aluminium sulfate. Okay, so let's vote before I can start. Can I go through them so that we mark ourselves, or I go to the next question? Our number one
Shall
question.
go through.
Again, those who want us to. Okay, sodium phosphate. Good. Let's start with sodium phosphate. Okay, so I need all of us to get our tables for radicals and to get the valences, so that as I'm writing, we can move together. Sodium phosphate, that means we have sodium as the metal and we have phosphate as the radical. So let's all check our table of radicals. What is the valency of a phosphate? Unmute. You can raise up your hand or unmute yourself and speak. Someone has said 3. Can I get another person to agree with her or to disagree with her? Phosphate. Shona? 3. How about for sodium? What is the valency of sodium?
1.
1.
So 1 comes here, 3 comes here. This gives us sodium. The 3 comes this side, then phosphate. Since there are 2 or more atoms in this radical, we put brackets and put a 1. But we agreed that in chemistry we don't write ones. Do you remember that? So since we don't write ones, we don't have to write this step with 1. I can write another one to show you the final equation, but you may not need to write that step that shows O and 4. That is what we call sodium phosphate. Good. Teacher Martha, are you okay now? Okay, let's go ahead. I've not
Yes,
seen
I'm
her.
okay, but I need to
Yes,
share
good
my
morning.
screen since I'm using my phone.
Okay, it's okay. Let me finish this number 2. Then you tell me if you'll be fine. So, girls, any question or questions on that number 1, sodium phosphate? Okay, Johanna, unmute
Yes.
yourself and ask.
I'm a little confused. I remember you saying that okay, in my understanding, when we're writing zinc nitrate, we put brackets and then put the 2 out. But then I thought we only put brackets because
Zinc nitrate, yes.
I thought that we only put brackets because NO carry N and O carry meant their own elements. That's why we put brackets. Or is it that when it carries a number already, you have to put brackets?
Joanna, you're breaking. Like, I'm not hearing you well. But we only put brackets if here the phosphate has 1 phosphorus atom and 4 oxygen atoms. So if this number was not a 1, because remember we don't write ones in chemistry. That's why you see I left it out. But if it was like a 2, I would leave it there with brackets because this radical has 2 or more atoms. I didn't hear your question very well, but can that one answer your question?
Yes.
Or you see on the left hand side, sodium is alone, just 1 sodium atom. You see, we don't bother putting brackets because a 3 is on 1 atom, which is sodium, so we don't put any brackets. Okay, so how many of us passed that number? If you passed it, just raise up your hand, then we clap for you.
Pardon?
Those who passed number 11 here, you can raise up your hands, then we clap hands for you. Okay, the number is increasing. Perfect. Thank you very much, girls. I'm going to do the last number. Again, we mark ourselves. Then we can go to our exercise. Good. I'm going to clean everything from the board or from our screens. Now, let me go to aluminium sulfate. Again, let's all get our tables. Those with notes. We have our sulfate. The first thing that you need to note down is to know the particles or the radicals and metal atoms or metal ions in the molecule. Here, since we have aluminium sulfate, that means we have aluminium and we have a sulfate. Mwebaze, your hand is up. Do you have an emergency?
No, teacher, never.
Okay.
Excuse me, teacher.
Good. Yes, go ahead.
Teacher, isn't it all 3? Or
Nope.
it's
AL3. Okay, I don't think I've understood your question. So, aluminium.
Teacher, she's asking for the valency.
Oh, thank you. So students, thank you very much.
We have just started.
Let's go to valences. We now have what we need, aluminium and sulfate. So let's move. Let's check in our tables. What is the valency of aluminium?
3.
3. Thank you. What is the valency of a sulfate? Let's open those tables of radicals.
2.
What is the valence of a sulfate?
2.
2. Good. I cross multiply or I interchange valences. Then we see that for aluminium, that 2 has come on aluminium. I put a 2 here. Sulfate, a 3 has come. A 3. Okay. Now you realize that a 2 and a 3, we don't have a factor in them and they must be there. Sulfate, you see it's 1 sulfur atom and 4 oxygen atoms, so we need a bracket here. Aluminium is 1 atom, we don't need a bracket. 2 and 3, there is nothing that can be divided through. So aluminium sulfate remains like that. So how many of us passed that number? If you pass that number, you can raise up your hand. Again, we clap for you, or we say thank you. Okay, thank you very much. I see many hands are being raised. So again, to start our exercise, thank you very much, girls, and thanks for trying out those numbers. So we're going to our exercise. Again, there are so many questions that you are meant to do today. So let me call upon Teacher Martha, if she's in, to say something. Teacher Martha, can you say something?
Yes, Mr. Angelo.
Yes, are you okay now?
I'm still failing, but maybe we can proceed.
It's okay. Okay, so exercise. So students, let's read through the question. Can I get someone to read for us this question? Someone can help me pick those hands. Teacher Martha or Teacher Silvery.
And let's hear from Umpire.
The valency of X in the following compounds. X is not the usual symbol.
State the valency of X. Okay, thank you. Okay, students, now here we have to be very keen and very careful. They are telling us to set the valency of X, but have given us the final formula. But are telling us X is not something that we know, so we need to keep our minds open. When we see X, our first example is X2 or 3. Remember, these 2 should have come from this side. These 3 should have come from this side. So that means that to go backwards, I'm going backwards. That means it was X with a valency of 3 and oxygen with a valency of 2. That is why we have X2 or 3. So in this case, the valency of X is equal to 3. I'm going to do 2 numbers. If you're still lost, You tell me. So I will ask you people to ask questions after the third number. That is number 1. Okay, part 2. I need all of us to check our tables. What is the valency of a hydrogen sulfate? Because here we see we have X and hydrogen sulfate. What is the valency of hydrogen sulfate?
1.
X hydrogen sulfate. Thank you. The valency of hydrogen sulfate is 1. So we have the valency of hydrogen. So you need to have that understanding from our notes. But if we look at the formula, it shows that here there was 1. No, we don't write 1. Even here there was 1. No, we don't write 1. So I will say that that means it was X1 H sulfate, hydrogen sulfate. Again, the superscript is 1. So from what we've seen, what is the valency of X in this equation?
1.
1. Okay, I'm going to do the third number, then we can start asking questions and we can start working together. Part 3. Okay, we have X nitrate. I need us to go to check our notes. What is the valency of a nitrate? Because we need to first remember that before we start doing this number, because we need to first identify the radical. Valency of a nitrate is
1.
1. Thank you. Perfect. So we have X and nitrate, but we now know from our table that the valency of a nitrate is 1. So let's keep it in our minds. We have a 2 outside nitrates. Since we are not seeing any number as a subscript for X, that means the valency is 1. Because you know, we don't write 1. Sorry, that means the number, the subscript is 1. Because we remember we don't write 1s in chemistry. Since we are determining valencies, we do the reverse. Because we say it later with time, when you understand these things, you don't need to show us the procedure. You can do it using a pencil, then you just write the final answer. But these ones will help us to understand only. But these steps in exams, you don't need them. When they say state the values, you can just tell us 1 or 2 if you can remember very well. So remember, these 2 came from this side. Again, this one came from this side. My arrows are funny. Okay, that means that as we are going backwards, X has a 2, a nitrate has a 1. But we need to first confirm. What was the valence of a nitrate? Someone told us 1. So that means this is perfect. So from this example, what is the valence of X?
2.
Unmute yourselves and speak.
2.
2, thank you. Okay, so those with questions, you can raise up your hands, then you ask. Those with questions, because I will need you to. Okay, I see Mary, Anna. You can unmute yourself, Mary.
Okay, what if the formula given was divided, assuming it was x4 and x2, then some radical which has a value of 4, and it was already divided. So how would we know that the valence for this one is this and for that one was that?
Okay, thank you very much, Mary. That is why, because I think I don't know if we have that example there. Yes, we have that example in these numbers. Oh, we have it. I'll check. That's why we say you have to first be sure of the valency of the radical. Like here we have a nitrate as 1. You first have to be sure that it is correct. If you have the valency of a hydrogen sulfate as 1, we are sure now that it is 1. Here we said the valence of an oxide is at 2, we are sure. But if you find that the valence here is 1, you have to remember that that 1 is not the valence of oxygen. So it implies that they multiplied through by a given number. I'm going to put an example to answer your question. Then we'll do it. I'm going to add it there. Okay, Mary, I'm going to add another example to answer your question.
Number 4 is there.
Another question. Okay, so I don't see any other question. Let me answer Mary's question. Then I will call upon you people to do part 4, part 5, part 6, and part 7. We'll be doing numbers together. I do one number, you do another. Do one, you do another, like that. So prepare to start working. I'm cleaning my screen. Can I clean my screen? Say yes if you've noted everything that you need.
Yes, teacher.
Yes, teacher.
Okay, thank you. So to answer Mary's question, we are going to add some example. Let's add CAX only. Just CAX only. Of course, in our question we have CAX2. That's another one. But let's assume we have CAX only. Now, Mary, pay attention because this is answering your question. This shows that in this formula, calcium has a valence of 1, has a 1 here, and X has a 1, because that is why we cannot write any number there. But we said you first look through the table and see what is known. What is known here is calcium. So let's check in our tables. What is the valence of calcium?
2.
Let someone unmute.
2.
It is?
2. Valency 2.
2.
Perfect, 2. So this shows that from the formula, perfect. This shows that from the formula, 1 comes here, then the other one comes here. And this one will give us Ca, calcium with a 1, and X with a 1. But now when you confirm, you realize that the valence of calcium is not 1, it is 2. That means that they divided through by 2, through by a 2, and by a 2. Because we know that the valence of calcium is 2, so we have to make sure that before we confirm the valence of X, the valence of calcium is known. So this becomes calcium 2, X 2. You see, again, when you cross multiply them, because there are 2 2's, you divide through to get 1 1, which will give me my formula back. But from here, it confirms that the valence of X is equal to 2, because it is only 2 that would enable this formula to be 1 1 after dividing through by a 2. Mary, do you think you've understood? And other students?
No.
Okay,
Yes,
I can't hear Mary saying something, but let's go to part 4. So can we try doing part 4, all of us? I need to do part 4 with some of you, those who think you cannot do part 4 on your own. And those who feel they can do part 4, start doing part 4. But we've added in some part, you add extra number, extra. Then you can add CA, X as extra to help you understand. Okay, I'm going to part 4. That is C. Those who cannot do part 4, raise up your hands. I see if I need to do it with someone. Because later I want you to share some work. Those who cannot do part 4. Those who cannot, if you cannot, I want to see if I should do it with a few students. Okay, I see 4, 6, 10. Okay, so let me do it with those that cannot do it. And those who can do it, start working. Okay, then we'll compare answers later. It is CA X2. In this case, it means that caesium in front of caesium, or sorry, the subscript for caesium is 1 and the subscript for X is 2. So those who are working with me, admit yourselves. What is the valence of caesium?
2.
2.
Before we get the valence of X, the valence of caesium must be 2. We have to make sure that they are fine there. So we start. I'm going to put, how did these 2 come? By, let me write another step. 1, X2. By exchanging. This came from here. This one also came from here. That means initially, before forming the formula, calcium was 2, then X was 1. Okay, does this make sense? So that means, so we need to confirm with our table. Is the valence of calcium 2?
Yes.
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 If the answer is yes, then we confirm that that gives us the valence of X as 1. Okay, those who are working on their own, what values of X do you have?
1.
1.
1.
Perfect. So can I go to, good. So can I go to part 5?
Yes.
Again, those who cannot do part 5, before I go to part 5, is there any question?
Teacher, yes.
Yes, teacher.
Yes, ask.
Teacher, like for that case when they ask you to state the valency of a given, let me say X, Y, is it possible, like let me say, like how you've given example, a free example where they can give you the valency of calcium if you exchange it's 1, but when it's not, is it like
We are not hearing you well. I don't know why.
Teacher, can you hear me?
You're breaking. Repeat your question.
I was asking, like how you gave us Cal
Mm.
and X when there is no valency. Is it a must that when they're stating a question, they'll give you the correct valency, or they'll just give you a wrong one to see if you know?
Oh, okay. Hope I've understood your question. Yes, we ask you to check if they use the right valencies. So in that, actually, we also have those questions here. Let me read for you that statement. I'm going to read for you number 4 right now. State whether I'm reading our number 4. State whether the following names of compounds are true or false. In this case, they want you to check whether they use the correct valences or the wrong valences. Now, in this case of ours, we don't know the valence of X. But to pick the valence of X, you must be sure, you have to first make sure that the valency of the other element that is attached to X that you know, its valency is correct. That's why in this case, where we had calcium with 1 and X with 1, we realized that the valence of X was not correct because the valence of X is 2, which implies that they had multiplied through by a 2.
Gabi.
I don't know if I picked your question well.
Hello,
Yes.
But do you think you've understood? Is it that no?
Yes, teacher. I've understood. Thank you.
You're welcome. Okay, I've muted everyone. So those with questions, unmute again. Next question.
Excuse me, teacher. Excuse me,
Yes.
teacher. Yes, I get now after giving us this number, I get
Yes, go
confused
ahead.
with like sodium peroxide. It has N2 and O2. So how come we don't divide like, the numbers to just put Na on O?
Repeat your question.
Yes, I was
Na.
asking that sodium, like when you're writing sodium peroxide, like
Yes.
Na2 then O2. Like how come we
Yes.
don't divide the valences or the two numbers to just put Na and then O?
Oh, thank you, Shona. Okay, thank you, Shona. Students, I'm going to repeat this, but we studied it last time. But I'm going to repeat it. We said, if you're writing sodium peroxide, last time we talked about sodium peroxide. So I think today let me talk about hydrogen peroxide. Okay, let's all remember. What is, let me start writing it. Yes, I have sodium. Students, what is the valency of sodium from our table? Just unmute yourselves and speak. We are answering Shona's question.
1.
Sodium is peroxide. Let's speak this. The valency of a peroxide, before we reach there, a peroxide itself is written as O2. O2 is the formula of a peroxide, meaning that 2 is already part of a peroxide. So we don't just play with it. It is part of a peroxide. So what is the formula? Sorry, what is the valency of a peroxide?
2.
Check in our table. Good.
It's 2.
So this 2 comes here, and this one comes here. So I said we should write this as this Na, that 2 has come, and O2. Since there are 2 atoms of oxygen, I can put a bracket. Then we put 1. But you see, 2 and 1, there is no common ratio.
Yes,
So do we need to write 1 in chemistry as chemist?
No.
No.
Let someone unmute and answer that question. Do we need to write 1 or we don't need to write it?
We don't need to write it.
So I'll write
We don't.
2 and I don't put 1. So the reason why we are not dividing through, thank you very much, girls. The reason why we are not dividing through by anything in this N2O2 is because the 1 is the valence, not 2. So this 2 is part of the peroxide as a radical, so we cannot touch it because it's part of the original radical peroxide. Shona, I think I've answered your question.
Yes, teacher, thank you.
You're welcome. So let's go to part 5, 6, and 7. How many of us can do those 3 parts? Because I need to skip them. I leave them for you. Yes?
Sorry to interrupt, but sir, I haven't, like, ever since we resumed class, this is the first time I'm attending the lesson and I don't seem to understand anything. Is there a place I can access the recordings for the previous classes?
By the it's a little hard because what you do now, you make sure that you download the notes. So that when I say valency, you understand where I'm coming from. So when I say valence, when you hear them telling me 2 or 3 or 1, they already have them. Then in the next exam, in the next number, you pay attention, you see how we are using valency. So for today, just try to follow what I'm saying. Then when you get notes and I think you contact me or you go on the website, these recordings should be there, you follow them. But first download the notes.
Okay, thank you, sir.
Mwebaze, and then I go to the next number. Okay, thank you. So on that note, can I go to number 2 so that I leave this one, and this one for all of you?
Yes, teacher.
Oh, teacher,
Yourselves and say yes.
teacher, no, leave 6 and 7.
I leave 6 and 7 only.
Yes,
Give 5 and 6 and 7.
Okay, let me do 5 from what I've had. Let me do 5, then we go to number 2. Now, for number 5, we have iron with a 3 and X with a 2. So we need to first remember, what are the valences of iron? Check the table. 2 or 3. It can be 2 or it can be 3.
3.
So that means that, let me write this well. That means that in this formula, X had 3 as a subscript and X has a 2 as a subscript. Now, 2 comes here because that means originally 2 was the valence of X, valence of iron, then 3 was originally the valency of X. We are going backwards from what we did last time. So that means iron is 2, then X is 3. So we need to first confirm. Is the valence of iron correct?
yes.
We have 2 or 3, so we are using 2. So in this case, what is the valence of X?
3.
Perfect. So we agreed number 6 and 7, they are yours to do. Let me go to number 2. Number 2, can someone read for us number 2?
State the valency of manganese in the following compounds.
Yes, go ahead. Part 1. Read part 1 and part 2.
1 manganese 4 oxide and 2 manganese 2 oxide.
Okay, thank you very much for that. We said that every time they put a number in brackets in 4 in front of a metal, it shows that that number represents the valency of that metal. Here they're saying manganese 4, manganese 2. So it means that manganese 4, here the valency of manganese is this 4. Manganese 2. In this case, the valency of manganese is 2. Okay, so on that note, I need us to write the chemical formulae of these two compounds, manganese 4 and manganese 2. Then we go to the next number. Can I clear everything on the screen? Okay.
Yeah.
I'm starting with manganese 4. So for manganese 4, which valency are they using?
4.
Good. What is the valence of oxygen? Let's check our tables.
2.
2 comes here. Now we are doing the original method. We are writing the formula. This gives us Mn 2 of 4. Now, these two numbers are all valencies. That means that we have to get the simplest formula. Are you seeing that idea? In peroxides, we couldn't because 2 was part of a peroxide. But in this case, in the oxide, the 2 here was not part of manganese, it's a radical, sorry, it is a valency. Even this oxygen was a valence of manganese. So we get the simplest ratio. Which factor do we have here?
2.
2 and 4. So we divide through by 2, divide through by 2. This gives us 1, this gives us 2. So I'll write it as manganese O2. Okay. Question number 1. Number 2. Part 1. Let me go to part 2. Now, manganese 2. In that case, what is the valence of manganese being used? Unmute yourself. Then valence of oxygen.
1.
Let's check our tables. What is the valence of oxygen?
2.
2. Perfect.
2.
So 2 comes here and 2 comes here. This gives us manganese 2. Now we have a question here. We have a challenge. Again, the 2's are the same and have come and they are common. What do we do about them?
We cancel them.
So we divide through by 2 everywhere. That gives us manganese
Oxide.
oxide as MnO. Any question or questions on number 2?
Teacher, I have a question.
Go ahead.
On the first one, manganese oxide. Since manganese has variable valencies, whenever they say like manganese 4 oxide, don't you know that the valency of manganese is 4?
Yes.
Okay, thank you.
Yes. When they say manganese 4, then the valency is 4. When they say manganese 2, then the valence being used is 2. When they say iron 2, the valence being used is 2. When they say iron 3, the valence being used is 3. When you read the name. Last question, Daphne.
Oh, teacher, I forgot my hand up.
Okay.
Teacher, I was asking, is it the same thing with copper and lead?
Yes. Copper 2, that means the valence is 2. Lead 2, that means the valence is 2 for lead.
Okay, thank you, teacher.
You're welcome. Eunice.
So teacher, if we know that manganese 4 oxide, the valence is 4, why do you need to do all that?
Oh, thank you. The reason why we need to put those valences because for them they have more than one valence. Like manganese can have, you can find that manganese has 4 as the valency, manganese can have 2 as the valency. So it
Yes,
can
teacher,
have
I get that, but teacher, I get that, but my question is, because number 2 says set the valency of manganese in the following compounds. So the
Just
Roman numeral 1 gives manganese 4 oxide. So don't you just say the valence is 4?
Yes, yes, I just did this to show you how we get the formulae, but our main goal here was to get valencies for that question. In an exam, you just tell them the valence is 4, the valence is 2.
Okay.
Okay, let's go ahead. Set the valence of carbon in carbon dioxide. Carbon dioxide is written like this. Okay, can we do this? I'm cleaning my screen.
Yes.
Carbon dioxide is like this. Carbon dioxide. Let's go back to our table. What is the valence of oxygen?
2.
2. So that means when we see carbon alone, that means initially this was 1 and this is 2. So 1 was coming from oxygen, 2 was coming from carbon. We are doing the reverse because we need the original valencies. Means carbon, there is a 2 here, oxygen, there is a 1. Now, this scenario came in one of the numbers that we did. We know that the valency of oxygen is 2. That means we don't have the correct valency here. What do we do, or what does that mean? Does it mean that they divided through, so we have to multiply through to get a 2? Or what can we do?
Can I answer?
Yes, go ahead.
Since the valency of oxygen is 2, so we multiply 2 with oxygen and carbon because before you divided, that's why it's giving you oxygen as 1.
Perfect. So that means I'll multiply through by 2. Also multiply through by 2, which will give me C4 and O2. That means now the valence of oxygen is correct. So we can comfortably go ahead and say that that means also the valence of carbon is, so what is the valence of carbon now? What do we write?
4.
Perfect. 4. Okay, number 4. I think that's our last number. We have, I see 7 or 8 minutes. So we need to finish those 4 numbers very fast. Now, I need 4 people to do these 4 numbers for us. So when I read number 1, I need 1 person to raise up their hand and tell us what they think. If it is correct or wrong, and they give me reasons why they think so. Kale, let's start. Number 4. Angel Tongo, you can read the question.
And state whether the following labels for the following compound are true or false. If the answer is false, give the correct name of the compound.
Okay, so who can do for us number 1, part 1, part A? Tina.
I think that A is correct. It's true
Give a reason for your answer.
because magnesium has a valency of 2 and chloride has a valency of 1. So when you interchange, that's the answer you get. The formula and everything.
So what I've shared on the screen, is it what you're meaning?
Yes, teacher.
Okay. Who can do for us number 2, part B? I see many hands. Let me pick. Someone who has not yet said something. Jovia. Am I saying Jovia? Yes.
I think
Jovia.
part B is false because the valency of copper cannot be 4. This when you interchange the valencies, it comes under oxygen, and the 2 also comes under copper, and you have to divide, which will give you copper or is divided. But I think the correct one is copper 2 oxide.
Perfect. So if we had copper 2 oxide, so what you're trying to mean, I'm going to write what I've understood. Then you tell me if it is correct. You're trying to mean that if it was copper 2, the valency of copper would be 2, the valency of oxygen would be 2, then you interchange them to give us C2, Cu2, O2, then you get the simplest ratio, which would give you copper 2 oxide. Is this what you're meaning?
Yes.
Students, do you think she's correct?
No, teacher.
Okay, why do you think she's not correct?
Because I think the valence is 4 for copper, and then the valency for oxygen is 2. So when you interchange, it's 4, and then oxygen is 2. And so when you interchange, it becomes Cu2, then O4, and when
My O is so big. Yes, we divide through by 2 to give us Cu or 2.
O2, yes.
Okay, thank you. So we have 2 people. Members, can I be the judge? Then we go to the next number for the case of time. When you check our table, we said copper can be having 2 valencies, the valence of 2 or the valency of 1. Check our table very well. So that means that copper cannot have a valence of 4. This working is perfect. This working here, it shows that you've understood very well. This working is perfect, but in the table we gave you 2 valencies, a valency of 2 and a valence of 1. So we consider that this copper 4 oxide should not be present because the 4 is not a valency of copper. Copper can have a valence of 2 or a valency of 1. So they say if this is false, so this is correct, and the name is copper 2 oxide. Okay, let's go to part C. I see we have 2 minutes. So the last 2 people be very fast so that you take only 1 minute each. Part C. Johanna, unmute yourself.
Teacher, I have a question. I think part A was now to be true. I mean false, because very true. I thought the answer would be magnesium chloride because Sir, can you hear me?
Yes, we are hearing.
Yes, I thought it's magnesium chloride because magnesium doesn't have another valency.
Okay, thank you. So number 1, yes, magnesium chloride, we finished it and perfect. Then do you have another, you want to talk about another number?
No?
Okay, thank you. Can someone talk about part C, or part C and part D should remain as your exercises?
Yes, it should remain as an
They should
exercise.
remain.
We didn't
Hey,
understand part B.
you didn't understand part B.
That's true.
Okay, any question, no questions? Because I still have 1 minute. We've agreed that part C and part D should be done by you people. Any question, no questions? Teachers, is there any question in the chat that we need to talk about?
Please re-explain part B.
Part B, okay. Let me remove this. So part B.
Responded to Mr. Ju.
Okay, thank you. For part B, we had two suggestions from you girls. One said would have written copper 4 oxide as this on the left hand side, you can see. Then another one told us copper 4 oxide is not right. It should be copper 2 oxide, which is like this. Copper 2 oxide. Let me write names to explain. After this explanation, we'll end our lesson. So copper 2 oxide. Then we said that it is true that if you check our table after this lesson, all of you can move to our tables. For radicals, copper has only 2 radicals. Copper can have a valency of 1 or a valency of 2. Those are the 2 radicals that we have for copper only. We cannot have a valency of 4 for copper. That is why we are not taking the name of copper 4 oxide, because they say state whether the names given are true or false. So this name we said is false because when you check this formula, to get this formula, you realize that we got it by using the valency of copper as 2. Do you check? Oh, I've put many lines on my screen. Let me use a few lines. You check that if we use, when we use 2, check here. Yes, I'm writing. When we use 2, realize that we got the right formula. But on using 4, like here on the left hand side, you see that we got a wrong formula. So that's why we said it is false. The right name was meant to be copper 2 oxide. Thank you very much, students, for those questions, and thanks for being very nice students. Part C and Part D, they are yours to do, and our lesson has ended. I think I've answered your question very well.
Thank you, teacher.
Thank you, teacher.
Bye-bye.
Thank you, teacher. Bye.
Thank you, teacher.
Bye.
Bye-bye.
Thank you, teacher.
Bye.
Bye.
Thank you, teacher. Bye.
Adios.
You are welcome.
Thank
Bye-bye.
you.
Bye.
Bye. Thank you, teacher.
Welcome. Shona, your hand is up. You can unmute yourself. Okay.